Hello everyone. In this presentation, we are going to understand how a TIVA Launch Pad is helpful for us to understand the UART serial communication between two launch pads here. So here the launch pad TIVA Launch Pad 1 and the Launch Pad 2. These two launch pads are communicating between both boards through UART serial communication. This is the transmitter board and this is the receiver board. So the received data is monitored in the second laptop, which is UART receiver, as you see here. And what data which is being transmitted? Transmitting data is coming from the transmitter laptop through the serial window. So the simple way here is, from the serial window, you are transmitting the data through USB. There is a USB to UART converter. So the TIVA controller receives the data in UART 0. From UART 0, we are transmitting through UART 1. From UART 1 it receives, and then through UART 0 it is sending back to this receiver. So transmitter laptop, receiver laptop. From the transmitter laptop, data comes to the TIVA board 1. From the TIVA board 1, it communicates with TIVA board 2. From TIVA board 2, the received data will reach the receiving laptop, and which we are able to see it here. So for example, I am going to type some data which is going to be transmitted here. So say for example, I am going to type welcome. So you can see in the serial window, WELCOME. I am typing the word welcome here, which is the data which is about to transmit it. So when you click send, this will transmit the data serially. So now I am entering, after giving enter, the welcome data, what is being transmitted, has reached the receiver as welcome. So welcome to, say for example, welcome to. Now I am pressing to, welcome to, and I am giving enter, means it is coming as welcome to. Welcome to LEARN, learn UART serial communication through TIVA Launch Pad. This is the message that we are going to send. So I have transmitted, welcome to learn UART serial communication through TIVA Launch Pad. It's coming here. It's very interesting. So this TIVA Launch Pad, through ENERGIA IDE, we are capable of transmitting the data from the transmitting laptop to receiving laptop. We will see the details technically very clearly now. So if you look at this diagram here, so this is experimenting UART serial communication with TIVA Launch Pad. Here we can see the PC, which the serial window we are typing hi means. From the PC, it transmits to Launch Pad 1. In the Launch Pad 1, there is a USB to UART converter. From this USB UART converter, it transmits the data to the UART 0 of our TIVA microcontroller 1. The data received from UART 0 is copied to the variable data. From the variable data, we are transmitting the data through UART 1. As we all know, there are 8 UARTs in the TIVA microcontroller, out of which we are using 2 UARTs. Receiving the data from the PC through UART 0 and then transmitting the data to the TIVA microcontroller 2 launchpad through UART 1 through the pin TXD1. Then the UART 1 of the launchpad 2 receives the data through RxD1, and this RxD1 data is copied to the variable data. From this variable data, we are transmitting to the second laptop through UART 0, TXD0, and this USB to UART converter or UART to USB converter converts this TXD UART data to USB data, and this is the receiver PC which receives the value data, which is high. High is being transmitted means high is being received. So this is the fundamental block diagram as we see. So the TXD1 pin of launchpad 1 is an alternate function of port B1, and which is in the 4th pin. So which is the 4th pin? This is the 4th pin. So jumper 1's 1, 2, 3, 4th pin is nothing but the transmit 1, which we are connecting it here. And the RxD1 is nothing but the 3rd pin. So 1, 2, 3, 3rd pin. So TXD1 of the transmitter board is connected to the RxD1 of the receiver board, as we see here. So TXD1 is fourth pin, RxD1 is third pin. So let us look at the code here. It's very simple code. Very simple code here if you see. So there is a simple void setup. So there is a serial begin. So we are serial begin means 9600 baud rate for serial port 0, 9600 baud rate for serial port 1. This is UART 0 and this is UART 1. And serial print UART transmitter. That is what it is getting displayed. UART transmitter. And in the loop, if we are transmitting any data means, that means if the serial available, that means serial available is greater than 0 means what? It is receiving. That is the loop whenever there is a serial data inside the microcontroller. That means if I am pressing some key means there is a serial data available. If there is a key means if I am pressing some key, there is an ASCII value. That ASCII value receives the data here. And then that data which is received from the PC is read through serial data and it reaches the character variable, and the character variable which is available in the data variable is being written through serial 1. Serial 1 means TXD1. So receiving the data through serial 0 and then retransmitting through serial 1, that is what we are able to see it here. So after getting transmitted, as we see here, if you look at the receiver code, it's very simple. So again we are initializing the serial port 0 and serial port 1. Here it is UART receiver. In the loop, we are receiving it through serial 0. Now we are receiving it from the board, TIVA receiver board, and whenever the receiver board is receiving some data means, serial port 1 is receiving some data means, reading the serial port 1 data and writing back to the serial port 0. So serial port 0 means what? It is communicating it to the USB and then will reach the receiver as we see here. So here the controller receives the data from port 1 and then retransmit through port 0 as we see here. Receives from port 1 and then retransmit to 0 in the receiver side. In the transmitter side, receives from 0 and then retransmitting through UART 1. It's very interesting to see this. So if you look at the TIVA Launch Pad's diagram, as you see here TIVA Launch Pad's diagram, you can understand very well. Here you can see this is TX and RX1, which is an alternate function for P0, PB0 and PB1, which is third and fourth pin. So where fourth pin is the transmitter pin and third pin is the receiver pin. So fourth pin of launchpad 1 is connected to third pin of launchpad 2 as you see here. So fourth pin of launchpad 1 is connected to third pin of launchpad 2, which is TXD1 in this launchpad is connected to RxD1 in this launchpad, which helps us to receive the data. So what is this black color wire? This is the ground. So if you see the top right corner, if we jumper 2's 20th pin is ground pin, which is 20th pin. So there should be a common ground. So common ground and TXD and RxD helps us to communicate between these two boards through UART serial communication. If you look at the block diagram, what is this UART is about? If you look at the block diagram of the TIVA microcontroller, as we see here, and as we all know, in the previous video presentations, we have discussed about the motion control peripherals, where PWM and QA we have discussed. This is the closed loop control system part has been discussed very clearly. And the other previous videos contains analog peripherals, where we discussed about ADC and analog comparator. Now we are discussing here about the serial peripherals. With respect to TIVA microcontroller, there are 8 UARTs, on-chip universal asynchronous receiver transmitter available in the TIVA microcontroller, out of which in this experiment we are using 2 UARTs. Okay. If we go to the features of this UART, which is the chapter, if you look at the data sheet, which is chapter number 14. So chapter number 14 is our UART transmitter and receiver, and if you look at this, these are the features. If we go to the block diagram means we can able to understand very clearly. So this is the UART block diagram, where you have a interrupt control, UART intercontrol register, DMA control register, clock control register, and there are 8 UARTs as we know very well. For that 8 UART cells, that is data register 0 to 07, and finally there is something like first in first out receive registers, and there is a baud rate generator, and there is a transmit registers, transmit 16 × 8 first in first out transmit registers, and then through that we are having a transmitter pin and UART transmit pin. There is a receiver pin, UART receive pin. As we all know, UART is a full duplex. And what is this serial IR? Here you can see transmit with serial IR transmit encoder, receiver serial SIR means it is not SAR, it is serial IR receiver decoder. Because of this serial IR, this can be directly connected to the IR pin, where most of the television receivers, most of the air conditioning systems, most of the LCD projectors are receiving the data only through IR, where through our mobile phone we are able to switch on the appliances through the mobile app because of the presence of this SIR and SIR transmit and SIR receive facility, encoder and decoder facilities available in this higher end microcontrollers. So this is what the UART part with respect to the controller. So to study the UART, we have to look at the block diagram in the data sheet, and the 14th chapter we have to understand very well, and there are 8 UARTs. After understanding this, we have to come to the launch pad. The another serial peripheral like TXD1 and RXD1 is 3rd and 4th pin. Similarly, TXD2 and RXD, TXD5 and RXD5 is in 5th and 6th pin. And if you look at the other side, if you see TXD7 is available here, so 8th transmit data pin. And if you look at this here, another alternate function of RxD1, TXD1 is 37th and 36th pin, RxD3, 3xD3 in 35th and 34th pin. Receive data and transmit data of UART2 is in 33rd and 32nd pin, and receive data of 7, that is 8th UART is this. So the n number of UARTs to communicate with, there is 8 UARTs to communicate with 8 peripherals with full duplex mode, which is more convenient with respect to TIVA microcontroller launch pad, out of which here we are using UART 0 and UART 1. So as you know here, if you see here, so it receives the data through USB, and through USB the controller is connected to UART 0 directly. This is how it works. And finally, we will write the code like this by using this launch pad. Use the code like this by using UART 0 and UART 1, receiving the data through UART 0, retransmitting it through UART 1, receiving the data through UART 0. Serial read means serial 0 read. Okay, reading the data, putting it into the variable data, and then retransmitting. Serial 1 write means you are transmitting the data through serial 1 means TXD1. UART 1 through UART 1 you are transmitting, and it goes here, it receives through UART 0, it transmits through UART 1, and then it receives through UART 1, and then internally it is copying back to UART 0, and then you are receiving the data like this, as you see here. So UART transmitter is here. So finally, thank you. I am typing the word thank you. So THANK, thank you is the word I am typing, and I am entering this, and you are able to see thank you in the receiver laptop. So with this experiment, we are able to understand how to use UART serial communication in TIVA microcontroller through TIVA Launch Pad. Thank you.